Hi there, and welcome to today's class. For today's class, we're looking at how to do chain rule differentiation via partial derivative. Okay, so here's what to note. Note that if I'm given a function z in terms of, let's say, two variables u and v, all right, I'm given a function z in terms of two variables u and v, such that u is a function of, let's say, two other variables, let's say x and y, and v is also a function of two variables, also x and y. Then my chain rule formula is that partial z over partial x is equal to partial z over partial u dot partial u over partial x plus partial z all over partial v dot partial v all over partial x. All right. So this looks like the total derivative. Just that for this, what I'm having here is actually partial and not total. Also, I will also have that dz all over dy is equal to partial z all over partial u dot partial u all over partial y plus partial z all over partial v dot partial v all over partial y. All right. So this is how we solve this for chain rule. What if I had three variables? What if I had three variables? What would be my formula? So let's say we had something much more complex. Let's say we had another function p in terms of u, v, and w. That's in this case three functions, such that u is a function of x, y, and z. V is a function of x, y, and z. And of course, w is a function of x, y, and z. So I have this. So what will be my formula? For this, the p all over the x will be equal to partial p all over partial u dot partial u over partial x plus partial p all over partial v dot partial v all over partial x plus partial p all over partial w dot partial w all over partial x. So this is what it looked like if I have three different variables. Also, the p all over dy is equal to partial p all over partial u dot partial u over partial y plus partial p all over partial v dot partial v all over partial y plus partial p all over partial w dot partial w all over partial y. All right, let's get the last one there. The last one I'll have that partial p all over partial z will be equal to partial p all over partial u dot partial u all over partial z plus partial p all over partial v dot partial v all over partial z plus partial p all over partial w dot partial w all over partial z. So this would be the formula for chain rule. For this case, if I have a function of two variables, all right, having x and y, and then for three variables having this. So this is what the formula looks like. Let's take an example and try to solve this together. All right, so let's take this example on partial derivative using chain rule. So we are given the question that if z is equal to 3u squared plus 2v to the power 5, u is equal to exponential x squared plus y squared, and v is equal to x squared plus y. Find the z over the x, that's partial z over partial x, and then of course partial z over partial y. So let's get this man solved. So first is first, solution. Bringing this one back, we have that z is equal to 3u squared plus 2v to the power 5. So we have this. First things first, let me get partial z all over partial u. That will be equal to, I'm seeing u just here. To differentiate 3u squared, 2 times 3 is 6. So it becomes 6u into 2 minus 1 is 1. And I have that one there. There's no u here, so it becomes 0. Let's get dz all over dv. Dz dv, there is no v here, so this becomes automatically 0. Differentiate v here, 5 times 2, 10, v to the power 5 minus 1, 4. So I have this. Okay, so what next there? Let u equal to, I have exponential x squared plus y squared. Let's get the v, let's get the u, partial u over partial x. How do we solve for partial u over partial x? A reminder, let me give you the shortcut for exponential differentiation. Now we said if y is equal to exponential x, that dy over dx is equal to exponential x. Now the concept of differentiating exponential function is very simple. Now what you do is this: differentiate the power, use your answer to multiply what I have here. All right, we've discussed this one before in our previous class, so you can check our previous class on exponential differentiation. Okay, I'll leave a link in the description of this video. Now back to this. So if I differentiate x, it gives you 1 times exponential x gives you exponential x. That's the shortcut. Also, if I have that y is equal to exponential, let's say 5x for instance, or let's say 5x cubed. Let's get this done. For here, dy over dx is equal to, focus on the power. The power here is 5x cubed. Differentiate 5x cubed. You get what there? 3 times 5, 15. X into 3 minus 1, 2. Then repeat this, exponential 5x cubed. So I'm saying this, the idea is simple. Differentiate the power, whatever you get, write it down here, then repeat the question. That's like your shortcut. Now if that's true, let's get this one here. For this one here, I will just focus on the power. What's the power there? X squared plus y squared. For x squared plus y squared, we are doing partial u over partial x. Differentiate x squared here, you have 2x. Y gives you 0 because there's no x here. So it becomes 2x, repeat this, exponential x squared plus y squared. That's the concept. Alright. So differentiate x squared gives you 2x, then repeat this. So I have this. Also, du all over dy is equal to, same concept. I'll just focus on the power. From the power, the value of, there's no y here, so it's 0. What I have here is y squared. Differentiate y squared, it gets what there? 2y. So it becomes 2y exponential, repeat this, x squared plus y squared. So I have this. Okay, so what's my next task? What's my next task? My next task is that I'm given v, so let me do it here instead. So v is equal to this. Let's get partial v all over partial x. What do we get? So from here, my only x term is x squared. Differentiate x squared gives you what there? 2x. Differentiate y, you have 1, so it's off. Next up, let's get dv, partial v over partial y. That's equal to, if I differentiate x squared, of course, there's no y here, so it gives you 0, it's off. Differentiate y here gives you what there? 1. So I have this. Alright, so with this, we've gotten the value of our different partial derivatives. Let's now record the formula and solve this. All right, so from here, let's recall the formula. Recall that from chain rule that partial z all over partial x is equal to partial z all over partial u dot partial u all over partial x plus partial z all over partial v dot partial v all over partial x. All right, input values, that's equal to partial z over partial u, that's this one here, gives you 6u. So I'm having 6u dot partial u over partial x is this one here, becomes 2x exponential x squared plus y squared. So I have this, okay, plus partial z over partial v, that's which of them? This one here, 10 v to the power 4 into partial v over partial x, that's this one here, 2x. So I have 2x. All right, multiply this, what do you have? So this is equal to 6 times 2, that's 12. 6 times 2, 12, x, then u, then this one here, exponential x squared plus y squared plus 10 times 2, 20 into x into v to the power 4. So I have this. All right, so I have this case here. All right, let's replace the value of u and v into this function. I'll have that dz all over dx is equal to 12x into u. What u? U is this one here, exponential x squared plus y squared into this exponential x squared plus y squared. All right, so I'm having 12x u. U is this value here, then bring this one down, plus 20x into v. What's v? What's v? So v is x squared plus y. So into x squared plus y all to power 4. So v to power 4. All right. Can we in any way simplify this? Can we simplify this? Surely. If we simplify this, this will be equal to, this will be, that means partial z all over partial x will be equal to, so these two are the same term and they are multiplying themselves. So I can rewrite this as saying 12x into exponential x squared plus y squared. This, since this now, you know, if you have a times a, that's equal to a squared. Now the idea is that when two terms are multiplying, you can raise the power 2. That's the idea. So if this is multiplying itself, this can be raised to power 2. So that's correct. Plus 20x into x squared plus y to power 4. So I have this. All right, so if you choose to, you can factorize. If you choose to, you can factorize. I have 12, I have 20, I have x, I have x. So take the factors. What are the factors common here? 4, right? 4 can go here to give you 3, 4 can go here to give you 5. So my factor here will be 4x. The HCF of 12x and 20x, your HCF becomes from here, the closest number here is 4. 4 gives you 3x here, 5x. 4 times 3, 12. 4 times 5, 20. X, so take x here, 1. This gives you 3. This gives you 5. So 4x becomes my HCF. Okay? Alright, if I divide here by 4, divide 12 by 4, divide 12x by 4x, you have 3. Okay, bring out 4x first, please. So 4x into, divide 12x by 4x. So I'm having 12x all over 4x. X cancels x, 12 over 4 gives you 3. So it becomes 3. I'm left with the exponential. So exponential x squared plus y squared all squared plus, next up, divide 20x by 4x. So it becomes 20x all over 4x. This cancels this. 4 here 1, 4 here 5. It becomes 5 into this. That becomes 5 into this one here. X squared plus y all to power 4. And I have this. So this becomes the answer of dz over dx. Alright, let's now get dz over dy. Alright, so my formula for dz over dy is basically the same thing. I'll just have to change this to partial y, change this to partial y, change this to partial y. The same thing. Alright, let's impute values. This is equal to, let's get dz du. Dz du is this, that's 6u. I'm having 6u into du dy. Du dy is this one here. That becomes 2y exponential x squared plus y squared plus dz dv. Dz dv is this one here. That's 10v to power 4 into dv dy. Partial d over partial y, this one here, that's 1. So I have 1. Alright, let's expand this. This is equal to 6 times 2 is 12. And I'm having u times y. I'll have the y first before the u. And reason being that u is a function, that's this. Alright, so in this case, you don't really take alphabetical order. The idea is that u is a function that has a value. So let that function come here. So 6 times 2, 12. Bring down y. U is here. Then this one here. That's exponential x squared plus y squared. Plus this times 1 is itself. So I have this. Alright. So here I'll have to resubstitute the value of u and v into this. And that's equal to 12y into u. What's u? We said u is exponential x squared plus y squared. So I'm having u as being exponential x squared plus y squared into this. So u is this, bring this one down, becomes exponential x squared plus y squared plus 10 into v to the power 4. What's v? V is x squared y. That's x squared plus y, right? X squared plus y into power 4. So I have this. Alright, these two can be simplified, of course. So that means I'll have that dz all over dy is equal to, these two will multiply to give you 12y into exponential x squared plus y squared all squared. Of course, we discussed this one in the first example. Plus 10 into x squared plus y to the power 4. Can anything factorize here? Yes. 2 can factorize. 2 can divide 12 and 10. So you can bring out 2. So if I factor out 2 here, alright, so divide here by 2, this will become 6. So 12 over 2 gives you 6y. Repeat this, exponential x squared plus y squared all squared plus 10 divided by 2 is 5. So I'm having 5 into, repeat this, x squared plus y all to the power 4. This, close your brackets. So this becomes the answer. Alright, so this is how we solve this question. So I've done a complete video tutorial class on partial derivative from the very scratch. Alright, to access the video, simply visit my website www.jonahemmanuel.com/courses, then go to second year undergraduate, and you can get the course and you have access to everything about partial derivative from the very scratch. Thank you and see you in the next class.